Thank you for that. Thank you for the introduction. Shannon Green, MD of Lindian Resources. Lindian's a junior ASX company. We have projects in Malawi, Tanzania and Guinea. Guinea is our primary focus, and Malawi is also quite a strong focus for us. Unfortunately, we're tied up in some legal wrangles with the vendor in Malawi, so we don't really we don't have a timeline on that project. The Guinea is all about bauxite. Anyone that knows anything about the bauxite space knows that Guinea is the place to be if you want to be in bauxite. Okay, just our usual disclaimer. Not allowed to believe anything I say today. Okay. A little bit of a phrase we coined a little while ago, just to give people context that didn't know a lot about Guinea or the bauxite space, because bauxite is one of those odd materials that a lot of people don't necessarily understand a lot about, but Guinea is really becoming what Pilbara is to the iron ore industry. The level of investment that's gone into Guinea in the last 5 years on bauxite projects is colossal. The multiples of billions on large-scale bauxite export projects is enormous. Okay, it's home to some of the largest export bauxite operations on the planet now. A lot of that export is going to China, feed the aluminium industry in China. We've acquired a project in the top of the Bauxite region, which is really central to the mass bauxite production that's now being exported out of Guinea. There's a lot of infrastructure in the region. Many billions, multi-user rail lines, etc., port facilities, transshipping offshore in the Atlantic to Cape Class and up to China-Max now. They're actually transshipping too. So all of the ingredients that you need for DSO-style bulk export, all there in abundance. Okay, our little piece of the country. Is a project up in the top of the corridor. It's had a couple of owners. Originally, the ground was held by CBG. The CBG, being the original mover of bauxite in Guinea, owned most of the bauxite ground. And through the decades, forced relinquishments and so forth, ground has transferred to different owners. Went through to a Canadian company at one stage. They gave the ground up, and the vendor that we're doing our deal with picked up the ground. Through our due diligence, the geologists on the ground with the work that they did in terms of mapping, sampling, reference work back to original CBG, Sangaredi study work, we actually believe that we discovered more of a conglomerate bauxite rather than a typical in situ bauxite. And that's really characterised by really high grade. We took 7 initial samples off our primary plateau. Each sample ran over 55%, 3 ran over 60%. And bauxite, well, that's a little bit unusual. It's also characterised by very, very low boehmite, boehmite being an alumina, but that won't liberate in a low temperature Bayer environment. So most of the global refineries can't liberate boehmite, and that's normally considered just part of the alumina that won't be liberated, and therefore there's no value in that, and so your contracts would be based around what your boehmite levels are. Typically for Guinea, 3 to 5% is the norm for boehmite. It's also characterised by very, very low contaminants. Guinea is already characterised by very low contaminants, particularly silicas and reactive silicas. It's quite important. Australian bauxite is characterised by very high silica, high grade but very high silica. Guinea is high grade, very low silica. Also, conglomerates are its thickness of profile generally considerably thicker than typical bauxite. Typical bauxite, if you had a 15 metre thick matrix, you'd have an extremely good plateau. Conglomerates can form to 30 plus metres, and we'll talk a little bit about that. If this drills out to be and proves to be a conglomerate, then it's literally going to be one of the largest, highest grade bauxite discoveries currently in the market. There's only ever been one other commercial size conglomerate located. That was in Guinea. That was the original Sangaredi that started the CBG bauxite mine, Guinea's first mine. That's the only full commercial scale conglomerate that's ever been found. So we think we may have found the second one. We have a very experienced team. I myself have been in this part of the world on bauxite projects for the last 8 years. Mark Gifford, our independent expert, bauxite geologist, extremely good reputation. He's worked on a number of large-scale bauxite projects through West Africa. So a very, very capable guy. Okay, just in summary, we've got two major plateaus. The names are a little bit unfortunate, but they're the names we inherited. So Buba Plateau is our conglomerate target. It's a 5 square kilometre outcrop, and that is literally a pile of conglomerate bauxite, and we'll talk a little bit about that. And our second major target is a Mamaya Plateau, and that's 11 square kilometres. We've done some initial test work on that. We don't believe that to be a conglomerate. We believe that to be a typical in situ. It's a very high grade. It's a beautiful plateau. It's very large. 11 square kilometres is a large plateau, even by Guinea standards. But we don't believe that to be a conglomerate. We have some other targets on the site that we're yet to do too much work on. But they're our two main ones, with Buba being our absolutely primary target at the moment. Okay, just a little bit of a map of where we are in the corridor, and a few of the who's in the current operating environment. You got the CBG operations at Sangaredi. That's the original bauxite operation in Guinea. That kicked off in the early 70s. Still mines today. They've just done a massive expansion, sort of $1.5 billion USD expansion to take themselves to 18 million tonnes per annum export. They direct ship load out of the port of Kamsar in the channel. That restricts their vessel size to Panamax class. You can't get larger vessels in the channel than Panamax. You have Rusal, the big Russians. They've just brought Dian operation online. And this map doesn't show, but they're connected to that multi-user rail line out through Kamsar. And same too with Global Alumina, that's the old BHP project. They are also connected to that rail line now. They both transship offshore to much larger vessels, capes. SMB, which is a Chinese joint venture between Weichao and Winning, they actually are now transshipping offshore to Chinamax as well as Cape. So going extremely large vessels. And the sort of export you're talking there, SMB currently exporting 30 million tonnes per annum. They're looking at ramping up to 50 million tonnes per annum. CBG's 18, they're looking at ramping up to plus 20. The other two on there are both 10 million tonne per annum export operations. Just to the south there of Kamsar, you've got Bofa. There's another 10 million tonne per annum operation in construction right now. So in terms of investment, there are billions pouring into Guinea, and there's some significant bauxite operations being brought online. And that's part of the equation when you're looking at trying to bring a bauxite project into the market. Obviously there's logistics, that's one big piece of the puzzle. The second part is where's your market? It's a busy market. There's no shortage of bauxite. The market basically stays in balance. So for a junior to take a bauxite project through, there has to be a very, very compelling reason why you haven't just got the same as everybody else and get in line and wait 20 years, whatever. So, and we believe that we have the compelling case. We have the investment destination, we're in the right corridor, and we have an amazing grade of product. Just a little bit of background about conglomerate versus typical bauxite. So typical bauxite for Guinea, it's high grade, it's good quality, forms on flat plateaus, 10, 12, maybe 15 metres of thickness. Pardon? 1 minute. Gee whiz, that went quick. Okay. Wow, sorry. The conglomerate bauxite is formed, the geological theory is that the surrounding plateaus of bauxite wash and erode into a valley, in this case into the Tanzania River Valley, and over time filled that valley up. And at another geological point in time, you had all the geological requirements for bauxitisation, water, temperature, right amount of pressure, and that pile of bauxite rubble, if you like, rebauxitised. Ostensibly that washed more of the contaminants out and boosted the grade to well over 50%. What also happens, and probably most importantly, is you don't get further formations of baumite. So a 55% assay in typical bauxite would normally yield boehmites of about 15%. We're still in the 3 to 5, which means that our product's going to be so attractive to a refiner because the available alumina is significantly higher. The grade's high and the available grade is high due to its chemical structure. And just some of the geological evidence to support the independent expert signing off on it being a conglomerate. This was taken from the field, surface samples on the top of the mound and samples from the bottom of the mound, compared back to the geological work done at Sangaredi and the original slides. And you'll see the slide on the left, figure 4, and figure 6. They're both from the top. One being Buba, figure 4, figure 6 being from Sangaredi, and figure 5 from the base of our outcrop, and figure 7 from the base of theirs. And you'll see that for all intents and purposes they could have come from the same rock. You'll see that the one very subtle difference, while they both look very pebbly, the slide 4 and 6 from the top, the pebbles are quite lenticular. Slides 5 and 7, the rocks are quite round. And again, the geological theory is that that's washed further down the river basin, bauxite being quite friable, it's rolled, it's knocked it around, and it's now rounded. This was a very, very strong piece of the geological evidence puzzle to support the case that we believe we found a conglomerate, not a typical bauxite. The real importance of this is the fact of, one, it compares back, but two, at the Sangaredi they were about 30 metres apart, so you had about 30 metres of thickness of this very high grade. They were exporting at 58% average bauxite, which is just colossal. Our two slides, they were 37 vertical metres by GPS. So that was proof of concept that supports the case that there could be at least 30 metres of thickness in the matrix of this very, very high-grade bauxite. And to put that into context, at 30 metres, that'd be, based on the geometry, that'd be about 300 million tonnes of the highest grade bauxite on the planet. And you just see there on the slide, just as I guess a bit of proof that, you know, you can't really get it wrong when you look at how different they are. Figure 8, that's basically what typical bauxite looks like. And figure 9, that's what our bauxite looks like. So it'd be very hard for 4 geologists in the field to get that too wrong, you would hope. Just on our timeline, we actually start drilling next month. Wet season is the only thing that may get further in the way of that. But that's where we're at. So we've got a very short 2-week, 34-hole drill program. That program is designed solely to test the total scale of this outcrop of conglomerate to see how big it actually is. How thick is it? What is its dimensionality? What does it look like? Therefore, what sort of tonnage are we talking about, and what sort of average grade consistency and contaminant consistency are we talking about? That's then going to give us exactly what we're sitting on for that one primary plateau. Okay, and I've been given the time up. So that's the drill program. It's very short, very sweet, and quite cheap. Thank you very much.